Hi, today we're going to learn about the product rule of exponents. Our goal is I can simplify exponents using the product rule. So first, we know we're talking about exponents. Let's discuss what x to the power of 5 actually means. So x to the power of 5 is really the same thing as x times x times x times x times x. And we have to ask ourselves, well, how did I know when to stop writing x's? Well, it's just because of this number right here. It's x to the power of 5, so I had to write 5 x's. 1, 2, 3, 4, 5. Now, I wrote this dot right here in between each of them to symbolize multiplication. We could have done it even quicker for ourselves and just written x, 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 x. Again, 5 of these, 1, 2, 3, 4, 5. Because remember that sometimes multiplication is an invisible operation. That means we cannot see it, but it is still there. So x to the power of 5 means x multiplied together 5 times. So similarly, we now have the question, well, what does x squared mean? X to the power of 2. Again, that's just x times x, or we could write that as x. Okay? X, I mean, pretty obvious, but the reason that we chose to use the letter x is because this right here says x. That is called the base. The base is what the exponent is attached to. So the exponent says, hey, here's the amount of times you're going to write that base multiplied together. So for this one, we're writing the base x multiplied together 2 times. Okay, well now we're going to get into something a little more challenging. Right here we have a multiplication symbol. That's a product. What we're going to be solving for right now is a product, hence the product rule of exponents. Well, we already know that x to the power of 5 actually means 5 x's multiplied together. So 1, 2, 3, 4, 5. Okay, remember we could have put the dot in between if we wanted to. We could have also not put the dot in between if we didn't want to. They're both correct. Now I have to do times, so just another dot, x squared, which we know just means x multiplied together twice, or 2 x's. 1, 2, our choice if we put that dot in between or not. So x to the power of 5 times x squared, or x to the power of 2, actually means x times x times x times x times x times x times x, 7 times. We could simplify that to x to the power of 7. So x to the 5th times x squared means, or is, simplifies to x to the power of 7. Okay, could we have done that faster, right? So in the last slide we actually wrote out x times x times x times x times x, and then put a multiplication sign and did times x times x. And then we counted until we noticed, oh hey, there were 7 of them. Well, could we do it faster? Yeah, you've probably even already caught on to that. But what is 5 plus 2? It's 7. So a quicker way would have been, instead of writing all of it out, we could have just added the 2 exponents. Now, the reason this works is because the bases are the same. Okay, so because this says x, and there's 5 x's, and this says x, and there's 2 x's, we know all together there are 7 x's. Later on we will look at what it means if the bases are different. So here's our product rule of exponents. Whatever our base is, okay, so in this case it's an x, to the power of, here's our exponent, times the same base, okay, and then whatever, it could be the same, it could be different. As long as those bases are the same, so here I have it at the bottom, when the base is the same, add the exponents. So add the exponents when the base is the same. So here's our exponent rule. Okay, here's some examples. Let's take a look at them. Some of them are going to be like what we just went over previously in these slides. Some of them are going to be a lot more challenging, and that's okay. So here, first, we always want to check, are the bases even the same? We have an x and an x, which means, yep, the base is the same, so I know the base at the very end is going to be an x. So then my exponents, we can just add those together. I mean, we could have written that out, right? We could have done x, 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 x times x, 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 and then counted. It would have been the same as just doing 5 plus 6, which is 11. So we've simplified to x to the power of 11. In fact, you have space on your notes. We could write that out. 1, 2, 3, 4, 5, just to remind ourselves, times 1, 2, 3, 4, 5, 6. And that equals 11 of them. Feel free to pause the video whenever you need to. Okay, I mentioned that it was going to get more challenging. Here it is. Here's the challenge. Our exponent rule only applies to the base that the exponent is attached to. So let's look at this term right here. We have a 4 and we have a y. So our exponent 3, what is it actually attached to? It's attached to the y. So right here, this means 4 times y, right? The letter y 3 times. The 4 does not have the exponent, so there's not 3 of those. It's just chilling over there by itself. Times, again, let's look at this term. 5 times y squared. The exponent is attached to the y, so that 5 just chills there, and then I have to write the letter y twice. Okay? Well, now we have our commutative property of multiplication, which just tells us that if things are all multiplied together, you can shift them in whatever order you want, which means we're allowed to move the 4 and the 5 to the front. So hey, I'm going to move that. Oh, and I guess I put them in the wrong order, and that's fine too. We can move them in whatever order we want, because 4 times 5 is the same as 5 times 4. So we've taken our 4 and our 5 and moved it to the front. Now if we really wanted to write out the whole thing, we could write y, 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 y. But we've already learned a trick, right? We've learned that we can just add them together, and instead of writing y, 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 we'll just write y to the 5th. And you can see the very last step, we simplify that. 5 times 4 is 20, so we get 20 times y to the power of 5. Okay, our next example. Oh yeah, this one's great. The base is not a letter. The base is a number. And not only is the base a number, but I chose the base to be a challenging number. So here the base is -2. Now the reason I put the parentheses there is not to trick you, but it's just to be very mathematically accurate. If I just put -2 to the power of 8, mathematically what this means is 2 to the power of 8, and then whatever you get, put a negative in front of it. And that's not what we want. Instead, we want an actual -2 8 times. So -2, -2, -2, -2, -2, -2, -2, -2, 8 times. That's what that very first term means. So -2 to the power of 8 means we have that number -2 multiplied together 8 times. Okay, here's our next trick. Not only did I throw in a new base, I threw in a new exponent. And that's an invisible exponent. Well, there's always an exponent here. It's invisible. How many times is this -2 written down? It's written down 1 time, which means I have all of those original 8, and I have another one. So I really have -2, 8 times, and 1 time, and when you put that together, you get -2 to the power of 9 times. And whew, that one was challenging, so we leave it for a slightly easier one. Here, our base is always the same. Woohoo, it's always a 3. Here it just means we have the number 3 4 times, so 3, 3, 3, 3, times the number 3 9 times, 3, 3, 3, 3, 3, 3, 3, 3, 3. Okay? Yes, absolutely. You are welcome to write that down. That's what I love about this, is that there are multiple correct strategies. You could write it down, or you could remember this trick that we've learned, which is you could add them together. 4 plus 9 is 13, 3 to the power of 13. Notice that the 3 stayed the same. That's because it's the base. The base always stays the same. Okay? Over here, I promised we would talk about when the base is different. Well, what does this mean? This means x 2 times, xx. And then this means y 5 times. 1, 2, 3, 4, 5. Well, I can't like add those together and say this is x, y 7 times, because there's not 7 x's. There's not 7 y's, there's just 2 x's, and there's 5 y's. So it doesn't change because the bases are not the same. And just as a reminder, the base is that variable or number, right? We've seen when it's a letter, we've seen when it's a number, that the exponent is attached to. Okay, that's the bottom of your notes.